Saxon Algebra 2, Lesson 26. We're going to talk about trinomial factoring. Last time we talked about monomial factoring, and we said that it worked like this. If you have something like this and you want to distribute it or multiply it, you end up with something like this, right? And then if you want to go back that way, that's called factoring, right? This is called distributing. I'm going to write it sideways because I want to use the space over there. This is distributing, and this is what we call factoring. Factoring is kind of pulling apart the pieces and separating things again. Distributing is multiplying it or mushing it all together. Now, that works when we just have a term like that right there. But what we're going to look at is what if you have something like this, and I'm going to write it with numbers. You've got it in this form, and then you want to change it into right? Going from here to here, we call that multiplying, right? We don't have a fancy name for that. We just call that multiplying. I call it doing the dance, right? The kids are in the studio on the Saturday morning, right? And we make them dance with each other. When we go from here to here, we call that factoring. Just like we did last time. Okay, so that's what we're going to practice. And we did this last year. We're going to practice taking something like this and putting it back into two binomials. So this is a trinomial, and we put it back into its binomial form. All right, and you'll remember the special little rules for this. Let's say we have this expression, x squared plus 6 minus 5x. Well, the first thing I notice about that, and I think about it as I write the problem down, is that's not in the right order. We know that things are always supposed to be in order of the descending x variable, right? We want the squared term first, and then we want the plain x term, and then we want the plain number term. So the first thing we do is just rearrange this. And honestly, you don't have to write it out of the book wrong. Just fix it as you write it down, all right? So I fixed it here. Now, we know that our answer is gonna look like this. It's gonna be two binomials, and we know there's gonna be an x here and an x here. Now, in these places, we know there's gonna be a number and a sign. And those numbers and their signs are going to do two very special things. They're going to multiply to the c term, and they're going to add to b, the number in front of the x. So we're looking for two numbers that will multiply to this and add to that. And you can do these in your head, but remember that if you get stuck or have any problems at all, make a list. What are things that multiply to 6? Well, 6 times 1, but that doesn't add to minus 5, right? What about minus 6 and minus 1, right? Play around with positives and negatives. That multiplies, but again, that gives me minus 7, not minus 5. Okay, the other thing that multiplies is 2 times 3. 2 times 3 adds to positive 5. I'm getting closer, and I realize, oh, if I do negative 2 and negative 3, then that will make a positive when I multiply, but it will add to a negative 5. So that is what I plug in, and that gives me my correct answer. Okay? So this is the rule that we're following. We are factoring trinomials that do not have a number in front of the x squared. If there's a number up here, that throws a monkey wrench into this. And we'll figure out what to do with that at the end of this year. But for now, we're not dealing with that, right? We're just using our eyeballs to look at these numbers and look at the patterns and figure out what are the possible pairs. These are factors of 6, and we just play around with them until we hit the right one. Let's try another. Okay, this one starts out with a bang. All right, at least John got it in order, but he put a minus sign here and I don't like it. Now, what we want to do is, we don't want that there. That's drama, that causes problems. X squared must be beautiful and perfect. We can't use this method unless we have a beautiful and perfect x squared. So here's what we're going to do. We're going to factor out a -1. Oh, it's so tricky, right? We'll factor out the minus sign. That will turn that positive, but we have to do it to everybody. So everybody else loses their positive sign and it goes negative. And again, we can double check this because if we multiply, we should get everything back. Okay, beautiful. Now, we're just going to leave that minus sign on the outside. And honestly, we can drop the 1. I'm just going to put it like this. And now we can factor this much of it, right? We'll just ignore those minuses. Two numbers that multiply to minus 14 and add to minus 5. I'm pretty sure it's 7 and 2 because that's really the only thing that multiplies to 14, except 14 and 1. This is minus, so one of these has to be a minus. And I can see I want the bigger number to be a minus because I want the sum of them to be negative. So that tells me that I should let the negative, right, be there. If I put the negative on the 2, then the sum would be positive 7. I don't want that. This is the way I like to see the answer written. What John does is he multiplies this minus sign times one of the other factors. So it could be minus x plus 7 times x plus 2, right? I multiplied the first one. Or he could multiply the second one, in which case we'd leave the first one alone and put it in the second one, minus x minus 2. I don't like either of those. Okay, this is John's choice. I think that's gross. I much prefer to see that minus out here so that I'm perfectly clear that he's just a minus sign, right? So there's a case where I disagree with John. I don't think his answers are wrong. I just think they're less desirable. I think this is the way to go. Yay. 26(3). Let's see how many there are. There's one more, and then we switch topics. All right, in this one, well, I see John's doing his thing. He's being his tricky little self. And he's written it all out of order. I consider that annoying. So the first thing I'm going to do is write it in the proper order. Which is nice, but I can see this is a problem. Remember how I said x squared has to be sacrosanct, pure and holy? Well, that doesn't look very pure and holy to me. So what we're going to do is we're going to divide all three terms by minus 3 and see what kind of magic we can create. That cancels, and finally I get the x squared of my dreams. 6 divided by 3 is 2. And I've got one minus sign, so that's going to be minus 2x. 24 divided by 3 is 8, so that's going to be minus 8. Okay, now I'm happy And honestly, let me say this. Let me change my mind. Instead of dividing by all of this, I want to factor it to the side. I don't want to divide. I want to factor it out. So I'm not going to look at it this way. I'm going to think of it as pulling it to the side. In this problem, it doesn't make a difference. This would have worked too, but I will say a word about that later. Let me just say, for now, we don't want to divide, we want to factor. Okay, now we're ready to factor this part of it. This minus 3 will just chill here. Numbers that multiply to 8, minus 8, add to minus 2. Let's see, it would be 4 times 2, and we need the 4 to be on the minus, right? So it's x minus 4, x plus 2. And then we can double check. They should multiply to minus 8, check, and they should add to minus 2, check. Okay, this should be the answer like this. In this case, because it's a number that we pulled out, it wouldn't matter if we just divided it and forgot that it ever existed. However, sometimes we will want to divide by an x. Excuse me. We'll want to divide by an x or whatever letters in the problem, a y or an m or whatever. And in that case, it's very important that we have that letter factored over here to the side instead of just dividing it into nothing. So we want to practice that. We don't want to divide when we're factoring. We can factor it out, but we don't want to divide it out. All right, so this is our final answer. Yay. And in this case, we wouldn't multiply this minus 3 back in. That's why I said I much prefer to have anything you factored out, just leave it right here in the front. All right. This one will illustrate what I'm talking about, what I was talking about here, which probably didn't make any sense. Ready? John writes this in a mixed up order. I'm going to put it in the correct order according to the variables. But you'll see it's still a bit of a mess. 2x to the 4th is the highest term, plus 12x to the 3rd. Okay. What I see is, what the heck? Where's my perfect x squared? I don't have one. I've got these in order going from big to little. This one's the x squared, but this is way too big. So what I can see is, oh, I have to factor out an x squared, right? I have to pull that out of all of these terms so that they will be the right size, because I want them to be like this, right? If I pull an x squared out of this, it'll be x squared. If I pull an x squared out of this, it'll be a plain x. If I pull an x squared out of that, it'll be a plain number, and I'll be happy. On the other hand, I still have to get rid of this too, though, because that's just ridiculous drama. So I don't want that minus 2 in there either. Now when I pull this out, I've got, okay, that's perfect. That's what I want. When I pull this out, I'm going to get a minus 6 and an x. And when I pull this out, I'm going to get, let's see, that's going to be a minus 16, right? And no x at all. Oh, I like that. Now, again, I just leave this 2x squared out here to mind its business, and I factor that part, same as always. Two numbers that multiply to that and add to that. Let's see, I think it's 8 and 2. And I think it's a minus 8 and a 2. Right? If you have any problems finding this, just write down all of the things you can think of that multiply to that. Start by making a list of all of those and then check their sum against that. But I decided it was this one, so it's x minus 8, x plus 2. That is the correct answer. This stays right there. No multiplying it back like John did in that first one. 1, 2, 3 different factors multiplied together. Same as here. The reason we don't want to divide away, like I accidentally showed you there, it would have been fine in this problem, but here we don't want to divide away one of our variables. We want to make sure we keep it. Later we'll talk about why, but that's what is important, is that if the variable is in the part that you want to get rid of, you don't want to lose track of it. When we divide it, it just goes away. But we want to make sure we keep this for reasons that will become apparent later. So that's why we should keep this one too. It just gets us in practice of doing the right thing. Okay. Overlapping right triangles. I gave you my speech about the color form triangles, right? Well, this is a variation on that. In this variation, the triangles are like this, right? This one is on top of the big one. We're supposed to find A, B, and C. And it kind of seems impossible because, gosh, we don't have much information. Okay. The first thing that comes into my head is I look at the angles. These two are the same. Let me draw them separately. That'll help. This makes sense. These corners are the same, so I can mark them like so. These are both right angles, so I can mark those the same. Aha! Now I know I have two angles that match, and that's the same as three angles that match. That tells me that these are similar, and now I know I can use proportions to solve for the missing sides. This triangle is A, 4, and 6. This triangle is A plus B, C, and this is 10. So now I'm looking for anchor proportions. Technically it's an anchor ratio, but I don't like to say anchor ratio. I like to say anchor proportion. So I know that 6 over 10 will equal, and now I look at the other sides. I look at this one, I think, dude, I don't want to mess with that one yet. That just looks horrifying. Let's do C first. That'll be C, 4 over C, right? And let's just make sure I got that right. It's little over big, little over big. Okay, that looks good. So then I cross multiply. 6C equals 40. Divide both sides by 6. C equals 20 over 3. That's correct. Okay. Now that we've got that, okay, now we can try to set up the one to solve for this. And we'll use our anchor proportion again. 6 over 10 equals A over A plus B. And this is where we hit that brick wall because we realize, wait, we can't solve this because it's one equation with two variables. It's not going to work. So we have to get creative and think of what else we could do. Well, I look at this and I go, we can solve for A using Pythagorean, right? Because we've got the two sides. So let's find A. A is equal to the square root of 6 squared plus 4 squared, which is equal to the square root, let's see, this is 36 and this is 16. So that would be the square root of 52. So what we can do now is put that in here, which is going to make a bit of a mess. I'm going to go down so I have a little bit more room. 6 over 10 equals square root of 52 over square root of 52 plus b. Oh, that looks like a nightmare, but let's just pretend it's going to be all right. 6 times the square root of 52 plus 6b. I'm distributing this as I go. Equals 10 times the square root of 52. Those two, right? Wolf to pig, 6b. All right? Well, let's subtract 6 square root of 52, and I feel good about that. 6b equals 4 times the square root of 52. Huh. All right. And then I'll go up here to finish it. I don't want to turn the page on all of my beautiful pictures. 6b equals 4 times the square root of 52. Divide both sides by 6. B equals, and then I'm going to take 2 out of top and bottom. 2 square root of 52 over 3. And the only thing that's left is that I'm pretty sure 52 has a 4 in it, right? I'm pretty sure it's 2 times 2 times 13. Yes, that's right. So here's a pair of pigs that I can take out and multiply against that wolf. So now we get B equals 4 times the square root of 13 over 3. That is my final answer. That is correct. This is A, square root of 52. Yes, B is that. That is correct. And C is this. Those are some gnarly answers. Look at that. That ends up being the cutest one. That's a monster. This we could simplify too, couldn't we? John doesn't. John leaves it in that form. I could argue that it should be A equals 2 times the square root. No, that's right. 2 times the square root of 13. I could argue that's even better, but I'm fine with that too. Okay, both of those. But this is how we show this one. All right, so this is another way that proportional triangles, similar triangles are often drawn, color forms side to side, right? Before we did color forms this way, where it was up here that we peeled them off, right? And then we would get information like that. But this is a slightly different kind of triangle, and we'll see those often. Okay, guess what? That's the end of lesson 26. I think that's quite enough, don't you? All right, thank you. Farewell.